mostly quiet. Primary feature of note is the incoming coronal hole system. They are both north and south. We will get effect from that solar wind in about 4 days, and right now, we are seeing minor variability in the plasma stream, possibly due to one of the tiny CMEs we identified at the end of last week. Either way, very minor perturbations. Since it is a new month, let's check in on the solar cycle progression. For those who don't know, the sun is ramping up faster than predicted in this cycle by about double, which is about 100 times faster than Zarkova predicted. Anyway, as you can see, we still have a long way to go before the biggest solar activity challenges our weakening magnetic field, but it's coming. By the way, excellent free-to-read paper on the Spanish power grid vulnerability to GICs, geomagnetically induced currents. Like much of the rest of the world, they are gearing up for the common 11-year cycle inductions, but still wouldn't be able to handle the big dance. Fascinating and honestly unexpected geophysics up next. Despite our continuing to break records for fastest cyclone winds and the like, overall wind speed over land has been decreasing for decades, and when we confirm that with the second paper on that topic this week, it's pretty solid. Earth's wind, at least over the land, is slowing down. Up next is an example of the identification of the three main features of the Taurus jet magnetic system model. This one is for a pre-stellar core, but it could be for a Type II supernova, galactic core nucleus, etc. Those three main features are the jet, north and south, that tends to follow the polar magnetism, the intermediate structure which mixes into the wavy rippling current sheet when you get further away from the core, and the torus field around the jet. To make this clearer, the middle and right side images should be swapped, so from inside to out it would be jet, torus, and current sheet formation fields. The next one really requires your having seen our recent video called You Don't Know Nova, and remember the bit about the small nova being hard to classify and sometimes jumping between classifications. Here, we have two more excellent examples of class-jumping nova events. The standstill moments are interesting features as well in their luminosity curves. Lastly, we've got two on magnetobiology. First one finds a change in body temperature due to an oscillation of a magnetic field. Now this is not the impact or the induction, but the reverberation of the field after the geomagnetic smack. Interestingly, the only mechanistic actors for this culprit would work on the atmosphere as well, but shh, Greta might be listening. Lastly, it's a confirmation study on the fruit effect. This team ran the study before and was criticized for their light choice, so they came back and said, fine, we'll do it your way. They found the same results. Losing the magnetic field negatively affects fruit growth. We were all over the place today.